Okay, good morning, afternoon, or evening, everybody. Welcome to the NASA Worldview Explore the Earth from Past to Present with Global Satellite Observations Earth Data webinar. This is your host, Jennifer Brennan. I've got 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. First, what I'd like to do is go over just a couple of logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or you have any questions, please enter those into the Q&A pod, and you'll find that located on the right side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earth Data YouTube channel within just a couple of days of completion. And then once that is complete, I will send an email to all registrants with the recording links. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations and an additional 15 minutes for the question and answer period. What I will do now is, excuse me, pull up today's agenda. Give me just one moment here. Okay, during today's webinar, we will have 2 speakers. Our first speaker is Minnie Wong. She is a systems engineer for the NASA Worldview project here at Goddard Space Flight Center. She will begin today's webinar with an introduction to NASA Earth Science missions, NASA's Earth Observing System Data Information System, or EOS-DIS, and also provide an overview of NASA Worldview and GIBS. From there, we will transition to this afternoon's second speaker, Jason Kent, who is a software engineer also with the NASA Worldview project. He will provide a live demonstration illustrating several different use cases, first as a media user and then as a hazards management user, all while also highlighting the key features and functionalities of NASA Worldview. Once he finishes up with these 2 use cases, he will transition to a demonstration that showcases the geostationary imagery layers within Worldview. And then after that, we will toss it back over to Minnie for a GIS user case demo and a demonstration illustrating a scientific user. She will wrap up with her portion of the presentation featuring the Worldview tour story and also highlighting the new Harmonized Landsat Sentinel-2 data imagery layers, and finally speak to a few future enhancements. Lastly, Jason will finish this afternoon's webinar by speaking to the capability to embed Worldview. And so once our speakers have presentation and live demonstrations, what we'll do then is we'll move to a final optional set of polling questions. We normally give these questions 3 to 4 minutes or so, and then from there we will move to the Q&A period. During today's question and answer session, we do have an additional speaker or panelist, and that will be Ryan Bowler, who is the project manager for NASA Worldview. And then just finally, excuse me, depending upon the volume of questions that we receive today, we will extend the Q&A period an additional 15 minutes from end time for those of you who either are able or who may wish to stay on the line, but we will have a hard cutoff of 3:15 p.m. We will try to answer as many questions as possible during the time allotted, but if we do not get to your question, our speakers will be able to follow up with you offline after the webinar. With that, it is my pleasure to introduce today's first speaker, Minnie Wong. Minnie?
All right, thank you very much, Jennifer. Can everyone hear me fine?
Not yet.
No, you cannot hear me?
Now we can see your slides. Thank you, Minnie.
And you can hear me now, correct? Okay, great.
I can also, yes.
Yes, wonderful. Thank you again, Jennifer, for introducing us, and thank you for hosting a webinar about NASA Worldview. So I'm here today with my colleague, Jason Kent, and we'll just tell you a little bit about Worldview. I will proceed. First, this is our outline. Jennifer already actually went over it, so we can skip over it and get right into the bulk of the presentation. So just to start from the very top, NASA, working with international partners, has a fleet of satellites orbiting the Earth, as you can see in that diagram there. taking different measurements and images. NASA also has instruments on the International Space Station, listed over here, like the lightning imaging sensor right down here, and also airplanes, balloons, ships, and on land. These global observations enhance our understanding of planet Earth by helping us to understand the interconnected processes and systems of this planet and identifying the effects of natural and human-caused changes. I'd also like to note that data collected by NASA are free for all to use. NASA's data policy ensures that all of NASA's data are available fully, openly, and without restriction. So NASA's Earth Observing System, which is the fleet of satellites, has a group called EOSDIS that is a core capability of the NASA Earth Science Data Systems program, which provides the end-to-end capabilities, that is from data acquisition by satellite or instrument to data distribution of the NASA Earth Science data. So EOSDIS is responsible for processing, archiving, and disseminating NASA's vast collection of data from Earth observing satellite, airborne, and ground-based missions, but also socioeconomic data. And this is totaling to almost over 41 petabytes of data. And that's quite a lot of data. Worldview and the Global Imagery Browse Services are the imagery visualization components of EOSDIS. So I'll go into that a little bit more, just going through this diagram right here. So here's the satellite. The data comes down into EOSDIS, and it's distributed active archive centers and science investigator-led processing systems for processing, archiving, and distributing data. So there probably should be another arrow that says it goes to the data side. But since we're just looking at the imagery side here, those centers, they generate imagery and vector data for Gibbs, and Gibbs then optimizes this imagery and vector data and openly serves it to any client via standard interfaces. So clients include things like Worldview, other web and mobile clients, GIS clients, and scripts and other utilities. So to describe what NASA Worldview and Gibbs is in more depth, so I just had a sip of water. With so much data available, like I said, 41 petabytes, it may be difficult for people without specialized software to view the data, or even the local storage space to download the data. Worldview and Gibbs makes it easier to access the Earth science imagery. We aim to provide a visual-first approach to finding and using Earth observations. So Worldview is an open-source web mapping application, which allows you to interactively browse NASA's global satellite imagery within hours of it being acquired, as well as imagery from the past few decades. Worldview aims to provide an intuitive interface to view and download the imagery, and then will also allow you to go to Earth Data Search to download the underlying data for further analyses. I'd also like to note that Worldview's code base is also open source and freely available for redistribution and modification. So Worldview is, like I mentioned before, is built on the Global Imagery Browse Services, which is a set of standards-based web services that provides fast and open access to 900 plus NASA imagery products. And lastly, also available is Worldview Snapshots, which is a lightweight, low bandwidth tool for creating image snapshots in a variety of file formats from a selection of popular NASA satellite imagery base layers and overlays like fires and thermal anomalies. Go talk a little bit about what Worldview and Gibbs provides. We provide satellite imagery and other kinds of data in 4 map projections. That's geographic or lat-long projection, Arctic polar stereographic, Antarctic polar stereographic, and Web Mercator, which is actually only available in Gibbs. We have raster, imagery, and vector data. And spatial resolution of this imagery and data ranges from 30 meters to 375 to 1 degree per pixel. And the temporal resolution ranges from 10 minutes, daily, monthly, yearly, and other time periods in between. And lastly, the latency, which is the time from observation by the satellite or instrument to availability in Gibbs and Worldview, is 40 minutes for geostationary, which is geostationary from geostationary satellites. 3 hours is from near real-time products provided through LANS, which is the land atmosphere near real-time capability for EOS. And latency can be longer for other products as well. So we have two different raster imagery types. One is the opaque base layers, which is basically, as the name suggests, a base layer. It's often things like this corrected reflectance image, a sort of true color image of the Earth on that particular day. And then we also provide overlays, which is like this chlorophyll A layer, which is colored in terms of, at least in this example, milligrams per cubic meter. I think that's what it says. And you can change these color palettes to a different palette, or you can threshold it. So if you're interested in certain values, you can concentrate on those values. Worldview and Gibbs also provides vector data. This is a relatively new feature we've provided. So we have static features, which support points, lines, and polygons. And you can get associated metadata and attribute information for user analysis. So in this example here, we have the fires and thermal anomalies layer from NOAA 20 VIIRS. It's over I think, Eastern Australia in September 2019. And if you click on one of the fire points, you get some detailed information such as confidence value, the latitude and longitude, as well as fire radiated power. So now we're changing gears a bit and moving over to the live demonstration section. Jason will give a brief overview of Worldview and Worldview through the eyes of a meeting user and a hazards management user. Then it will be back to me for a GIS user and a researcher scientist. So over to you.
Okay, hello everybody. Quick confirmation that you can hear me.
I can hear you.
Great. So we're going to start by going into Worldview here, worldview.earthdata.nasa.gov. And first we're just going to go over some of the basic interactions. So Worldview is a web-based mapping application, and so some of the basic interactions that you might be familiar with from other mapping applications like Google Maps will be here. So clicking and dragging to pan, scrolling the mouse wheel to zoom in and out, and of course we have buttons for zoom as well. That's all here. One of Worldview's fundamental features is the ability to observe imagery over time. So data from dozens of satellite instruments are constantly being processed and made available to Worldview as they become ready. And because of that, when viewing imagery for the current day, like we're seeing here, you may notice that it suddenly cuts off in the middle of the map. And that's because the satellite providing this imagery hasn't completed its full set of daily trips around the Earth, and also that imagery hasn't been fully processed yet. And in order to better visualize that satellite overpass, one of the things we can do is turn on an orbit track layer for a given imagery layer. So in this case, I'm going to come over to the sidebar, and we're looking at this corrected reflectance layer, and I'll click on this options button, which will open a dialog where we can see a checkbox next to orbit tracks. I will click this, and now we can see the orbit tracks on the map. So with these, we can see the path the satellite is taking on each orbit, and we can also see exactly which time the satellite is over a given area. So one of the first questions that people have when visiting Worldview for the first time is, what are these black bars in between the imagery? I don't see this on Google Maps. I don't see this elsewhere. What is this? So this is simply a gap between one overpass and the next. You can kind of see the orbit track runs right down the middle, and this is just the maximum width of the sensor for this particular satellite. And if we use a timeline to step forward and backwards in time, we'll see that one day's gap is another day's center line, basically. So you have alternating coverage across days. Another major highlight of Worldview is that it offers over 900 different imagery layers, including a wide variety of Earth science data measurements covering atmosphere, land, and oceans. Additionally, there's a variety of reflectance layers showing near real-time imagery of the Earth's surface, as we're seeing here, as well as a handful of layers featuring socioeconomic data, such as population density. And given the wide variety and sheer number of layers to choose from, we offer a couple of different ways to find which layers might be of interest to you. So to add layers to the map, we're going to come over to the Add Layers button in the sidebar and click on that. And now we're looking at the layer picker. So one of the ways to browse layers is to simply browse by category. So for example, I'll browse through the air quality category. And then within each category, there's a series of measurements. In this case, I'll choose aerosol optical depth. And then within each measurement, the layers for that measurement are broken down even further by source, satellite, and instrument. And so we'll see these choices here on the left. And if you see this symbol, the sort of disabled symbol, this is an indication that this particular layer doesn't have coverage for the date that you're looking at. So in this case, we're looking at today, and we see that this particular set of imagery stopped somewhere in 2010. So to add a layer to the map, we'll just check a box next to a couple of these. Then we'll move on to the other way you can find layers. So if you know more specifically what you might be looking for, you can transition to the searching and filtering mode by either clicking the filter button or by simply clicking in the search bar and starting to type. So for this example, I'm going to type out sea surface temp, and now we can see we have about 61 results out of our 986 layers for this projection. And from here, we can filter down our set of results with these facets on the left. So starting at the top, the coverage facet is going to be a way for you to filter out things that you would not be able to see today, but not today, but rather the day you currently have selected. So in our case, that is today. Most of these layers have imagery for today, so turning that on doesn't filter out much for me. But I'll come down, we have category filters, measurement filters, source filters. For our examples, I'll just use Aquamodus. And then you can also filter by time period, so daily layers, 8-day averages, monthly averages, so on. I'll choose daily. And then you can also filter by day or night. So in our case, I'll choose daytime. So now I've got a much more reasonable set of results to look at more closely. And with these, I can click on a row, and I will see some details on the right. At the top, I'll see a preview image of what that layer might look like once I've added it. So to add the layer, I'll just click the Add Layer button. You can also click the checkbox next to the row. Okay, moving along, we'll talk about the layer panel. So now that I've added these layers, we can see that they are here now on the side panel. And in the side panel, I can turn on and off individual layers or show and hide them by clicking this eyeball icon. So now I've turned off the sea surface temperature layers. Things are looking pretty cluttered, so I'm going to go ahead and remove this orbit track layer with this remove button. And from here you can also drag and drop layers to reorder them. So for example, I might want to put this coastlines layer on top of everything else, and that way I can get a better visual indicator of the borders of land masses on top of the data I'm looking at. Another way to sort of organize your layers in the sidebar is grouping. So if I turn on the group similar layers functionality with this checkbox here, we'll see that now the layers are grouped by type of layer. So on top we have reference layers, our coastlines and labels. Below that, the sea surface temperature layers are grouped, and aerosol optical depth layers are grouped. And so with the groups, you can collapse them if you want to take up less space, and you can also click to drag and drop to reorder just like you can individual layers. Moving down to the bottom of the screen, we'll talk about the timeline. This is how you'll navigate through time while viewing imagery. So at the far left, we have year, month, and day entry fields, and with these, you can manually type in your selection, or you can click through to change your selection. Here we have the step forward and backward buttons, which in our case right now are stepping forward and backwards by 1 day. You can also change this to month or year, or even a custom interval of any number of months, days, or years. We'll skip over the animation for now, come back to that later. On the right-hand side, you'll see the timeline scale. So we have a sense for where months begin and end, and each tick mark right now is representing a day. We can drag the indicator along the timeline to pick a different day, or we can just click a particular spot to move to that day. So right here we'll have the layer coverage panel, and what this is going to do is allow us to better visualize when the layers that we're looking at actually have available imagery. So I'm going to turn back on these sea surface temperature layers. Right now we see that all the layers that are enabled have coverage for pretty much the whole range we're looking at. We can get a sense for the overall coverage by looking at the dates on the right. So it looks like most of these started in 2002. We'll just jump back a few years just to, there we go, just to give them an indication of what you see if a layer doesn't have coverage. So now we see on this particular date, and for this whole range on the timeline, the only layer that has coverage is this corrected reflectance layer. Okay, so that wraps up our basic overview. Now we're going to talk about how you might use Worldview as a media user. So Worldview is often used by media professionals to share imagery of current natural events. For example, our imagery has been featured in Forbes, The Washington Post, The Guardian, and other publications. So for this example, I'm going to use the Australian wildfires, and the first tool I'm going to highlight is the location search. Up here we have this magnifying glass icon, and this will allow us to search for a place in the world, in our case, Armidale, which is in New South Wales. I will click the first result to zoom into that location, and it will also place a marker on the map for me at that location. So now that I'm here, I'm going to minimize this tooltip because I know where this is. I just wanted to navigate to it. And since we're talking about fires, I've added this fires and thermal anomalies layer previously. I'm just going to go ahead and make it visible. Now we can see the fire points on the map. And I'm just going to step through time to see how these fires started somewhere around the 5th and then started to grow over time as I advance the days. Now if I see something I like and I want to save an image of it, I can use the snapshot tool. And to do that, I'll come up here to the camera icon. On that, this will give me a box to drag and reposition over where I want to capture an image. We have a few settings for choosing different resolution and format. And when you've got that all set how you want, we'll click download. This is going to open a new tab hitting our snapshot service, which will just provide me with a big JPEG image of what I was just looking at. I could right-click and save that to my desktop and send it to somebody or put it on my own website. Another way to share what you're looking at in Worldview is to simply give someone the URL that you're looking at currently. And the easiest way to do this is to use the share tool. So this button here on the toolbar will allow you to copy a link of the current URL. And you can also shorten it with this shorten link checkbox. This gives you a much shorter, cleaner URL, which is really nice if you're going to put this in an article or print it in some way, because the URLs can get pretty long otherwise. Once I've copied that, for example, we'll show here, if I paste it in and hit enter, it's just going to take me back to exactly what I was looking at. So moving along to our next user example, this is for the hazard management user. Worldview can be a useful tool for hazard management, whether you're looking at wildfires or severe storms and their aftermath. We have a variety of layers and tools to allow you to visualize and analyze the impact these events have on our planet. So the first one I'm going to talk about real quick, we've talked about them a little bit, but the fire vector layers. Okay, so with the vector layers, you'll notice there's a pointer icon here in the sidebar, and this is your indicator that this is a layer that has vector points that can be interacted with. And so as many indicated, you can click on individual points, and this will bring up a dialog box with details about that specific point. The next tool I want to highlight is the comparison mode. So to enable this, I'll click Start Comparison. And now I've got two sets of layers and two dates in the sidebar here. And so for this first one, I'm going to set, try it again. So for the A side, I'm going to set 2019, January 13th. And for the B side, I'm going to set 2019, January 11th. No, 2020, I'm sorry. Okay. So with this, you can drag the slider left to right, and you can see different layers or the same layers at different dates side by side. And for this example, we're looking at essentially before the fires on the A side in 2019, and then after the fires on the right side, you can see these burn scars where the land has burned out. So that is it for the hazard management user. Now we're going to transition, well, the next one's a little bit related. So we're going to transition to a video explaining our geostationary layers and our animation capability. Copy. So geostationary layers. I'm going to try to keep this pretty quick since we spent a few minutes on the video. We're looking at this corrected reflectance layer here, which is only 1 day increments, so we can watch the storm move, but there's a lot of stuff happening in between those days, right, that we can't see. So to see some more detail, I'm going to add a geostationary layer. I'm going to add this red visible layer from the GOES East satellite, and I can see here this updates, or it has imagery at 10-minute intervals. And we'll also note that these geostationary layers only have imagery generally for the most recent 30 days. Our example, we have a historical range that's kept for demonstration purposes, but normally you would not see imagery this far back. Okay, so now we're looking at the GOES East layer, and I know that it has imagery in 10-minute intervals, so I'm going to set a custom interval here on the timeline to match that. So I'll set 10 minutes. Now, when I step forwards and backwards in the timeline, we'll see storm update in 10-minute intervals. Now I'll show how you can use the animation tool to watch the storm move in real time. So for this example, click on the animation button, which brings up this widget. And from here, we can set the time range. I'll set this to be about 2 hours worth of time. I'm going to adjust the frame rate, be a little bit higher than the default. Here I can turn on looping, which I will do. And then I'm going to go ahead and hide the sidebar here. And I'm going to hide the timeline over here. And this just gives us some more visual real estate to watch the animation play out. So when I'm ready, I'll click play. And after prefetching some of the imagery, we will see the animation. And so this may look a little choppy on the stream, which is why we were trying to use the video. But you can, of course, go to Worldview and watch this happen in real time on your own computer. So once you've got a cool animation, you can also export it as a GIF. And with this button here, this works very similar to the snapshot tool. You'll get a box, a bounding box to select the area that you want. And here we can see the parameters we set in the animation tool, start date, end date, and frame rate. And we'll just click Create GIF, and it will fetch the imagery. And then it will start to bind that into a GIF. And now we can see the GIF playing out. And from here, you can just click download to save it to your computer and share it with your friends. Okay, that concludes the geostationary demo. We're going to pass it over to Minnie for some more user demos.
Great. So I am going to just talk about how a user might use Worldview as a GIS user. So in this demo, we're going to look at Iceberg in Worldview's Antarctic view and measure the area and distance of the iceberg, export the image as a geotiff, and bring it all into a GIS client. So here we go. As a GIS user, I'm interested in Antarctica and icebergs that are in Antarctica. This is the Antarctic view that you can change to in Worldview by clicking on the globe icon in the upper right corner. So if you click on this switch projection, it'll switch back to geographic, and choose Arctic as well, as I mentioned in my slides, and Antarctic. So as a user, I came across this article in the earthdata.nasa.gov website where we see an iceberg forming after a calving event on the Brunt ice shelf in Antarctica. This image was captured on 1st of March 2020, and if we click on the link in the article, it'll take us right to that spot where the iceberg calved. So here you can see the iceberg in the center of the image, and we're just going to measure the area of this iceberg. So click on the measure tool, which is a little ruler icon in the lower right corner. If you click on it, you get to see these options for measure distance, measure area, and remove measurements. So let's click on measure area. So you click once to add a point, and click each time to add another point around the object, and then double click to end. So here we see it's not very well drawn, as you see when I zoomed in, but it's about 1,322 square kilometers. You can also go back to the ruler icon for measure tool to change it to square miles if you are more interested in seeing it in miles. So that's about 510 square miles. So that is the area of this iceberg, and apparently it's about 20 times the size of Manhattan in New York. So very large. So let's see how much the iceberg moved in a few days. So I'm going to change the date in the lower left corner to March 22nd using my keyboard. enter, and you can see the iceberg has moved quite a bit from the ice shelf. So let's see how far it moves. So clicking back on the ruler in the lower right corner and click on measure distance. You can measure the distance from the ice shelf to the iceberg, and it's approximately 7.95 miles. Again, you can go back and change it to kilometers. So now it's 12.8 kilometers, and the iceberg is 1,300 square kilometers. So now that I've gotten this information, I'm going to download this as a GeoJSON so I can bring it into my own GIS. So here we are going to save it to my computer. There it is. And then remove the measurements. Click on the icon to remove measurements. Now I'm going to zoom out a bit using the zoom buttons. And I'm going to take an image snapshot of this whole area so I can bring this into my GIS as well. So you have an option of downloading JPEGs with JPEG or PNG with world file, or just a GeoTIFF, which already has the georeferencing information in it. And here I click on download, and it should save the image to my desktop. And all right, now we're going to go to QGIS and see if we can open everything. So I've already loaded a coastlines layer from the British Antarctic Survey, just so you can see if it falls in the right place. So I click on layer, add raster layer, and navigate to my GeoTIFF. Click on add. You can see it's been added up here, and this is where the brunt ice shelf is. And there you can see the iceberg. Now I'm going to also add the GeoJSON where we have the measurements. Add vector layer, and we'll add view measurements. Click on add, and since it's a polygon and a line string, it'll add them as two separate layers in QGIS. And as you noticed, it hasn't appeared on the map. That is because it has no projection information. So I will change the projection information to 3031, which is polar stereographic. And there we go. There's the area measurement. And do the same for the distance measurement. 1. Oops. And there is the distance measurement. And if you right-click and look at the attribute table, you can see it has the size and units in the table. So I think that's all I want to show you one more thing in QGIS. So as I said in my slides earlier, you can also access the imagery via standards-based web services. So you can actually access the GIDS catalog through WMS and WMTS. So here I've already added it in. You can go to the website that I'll share with you later to find out what layers we have and find out the URL. But these are the layers we have for this particular projection. We have a lot of different brightness temperature layers. I can quite open it. And just many different kinds of layers you might be interested in looking at. So that is that for the GIS user. Now I'm going to change gears a bit, and we're going to look at Worldview as a researcher or a scientist. In this demo, we're going to look at the Events tab that you can see here in the layer sidebar. We're going to look at the Soufriere volcano that erupted recently, load some ash plume related layers, and then download the underlying data via Earth Data Search. So just to say, scientists have found Worldview quite useful for just getting an image ready for publication, using it for search and discovery and access to scientific data. And also, like Jason mentioned, it's helpful for enabling exchanges in between scientists. So just even like scientists using Twitter to share their latest find in Worldview, it's very helpful for them. So here we go. Let's start and click on the Events tab. And I'm going to click on volcanoes. So this is a curated list of recent current natural events occurring around the world from the Earth Observatory Natural Events Tracker website API. So here we click on Soufriere Volcano, and you can see it falls right in the swath gap. What we can do, change the day, and you can see it's right there in the center. See the ash plume if we turn off the sulfur dioxide layer. So here's the ash plume right here, and it's it was erupting quite a lot. So I'm going to now change to a different satellite sensor, and this one has a afternoon overpass while Terra Modus had a morning overpass. And I am going to add some layers that are related, that are taken from another instrument on the same satellite. Here we go to the ash plumes category and click on sulfur dioxide, roaming NPP umps. I'm going to add these four layers. So if you zoom out a bit, you can see actual sulfur dioxide plume emanating from the volcano. So these are showing sulfur dioxide levels in different levels of the atmosphere, heights in the atmosphere. So this is the upper troposphere, middle troposphere, lower troposphere, and planetary boundary layer, which is getting closest to the Earth's surface. And another we might want to add is aerosol index layer. So I click back on add layers, and we're going to go to aerosol index, again, Suomi NPP, and I'm going to click on aerosol index pyrocumulonimbus. So you can see the ash plume here is showing as high aerosol index in the center, and if you hover over the different values on this overlay layer, you can see over on this side, on the left side, the data values change, so you can see what the approximate values are at wherever your mouse is. You can also change the opacity, so you can look through and see the ash plume underneath. But also you can threshold the values. So say I don't want all of these lower values that are just covering everything else up. I'll threshold them out. Now you can really see just the spot that's all over the volcano. And also I don't like the color, so I'm going to change it to blue number 7. And here we've changed the color and the thresholds. So now that I've decided, I really like this aerosol index layer, I'm going to go download it from Earth Data Search. So click on the download tab in the sidebar, data tab, and we select standard under aerosol index. And then I only want to download the data around the volcano. So we're going to set the area of interest. And we'll draw a box around the area of interest here. And here you see we're going to download 2 of 14 granules via Earth Data Search. Click on that and continue. And we are now taken to Earth Data Search. Oh, and it's logging me in. For some reason there was an issue there. It's working right now. So you can see here, this is in the cyan blue box. That's the box we drew in Worldview. And you can zoom in, and you can see the same pyrocumulonimbus layer loaded underneath. And these are the 2 swaths we can download. So you can click download all, and it'll give you different data access methods, but in this case, just direct download. Download data, and it'll give you data download links, or also access to a download script. That is how you may want to bring it onto your computer. So we're just going to give one last quick demo on Worldview, kind of bringing it all back to the beginning again. When you first start Worldview, you will often see this window. We call these our tour stories. We have quite a few now, but the first one is a tour story, which is a basic introduction to Worldview. So it will just take you around the map, the application, and show you the different features that we have been discussing today. What I wanted to highlight to you is this is how you get back to the tour stories. You can click on the I button in the upper right corner and click on Explore Worldview, and you get that window back again. And I'm going to show you the new 30-meter resolution imagery we have in Worldview. For quite a long time now, we've had 250-meter resolution daily global imagery, and that was our highest resolution imagery at that temporal resolution. But now we have this harmonized Landsat Sentinel project data coming from Landsat 8 and the two Sentinel 2A and 2B satellites. And the most exciting thing is here in step 3, you can see how much higher resolution it is. So this is New York City. And on the left is the Lotus image, which is quite blurry. But now I move the comparison tool over, and here we go. New York City comes into view. You can even see Central Park, and I don't know the names of the bridges, but the bridges. And so it's very much it's much higher resolution, and it's really great to see this imagery in Worldview. So please feel free to peruse all of our other tour stories and learn more about Worldview and events that have occurred around the world. All right, so now we will go back to the slides. Let me find the slide. And we're just going to talk about some, and Jason will talk about Embeddable Worldview widget. I'll talk about Granular Swath Viewer and a new data product called the GOES GeoColor Layer. So over to you, Jason, if you just want to talk to this.
Okay, I'll try to keep this quick since we're running a little bit behind. One of the feature requests we've received from several users is the ability to add an embeddable Worldview widget to the website. And you can do this now with the full Worldview website, but it can be a little more bulky than you'd like for an embedded application. So we're working on ways to slim down the interface in embedded mode to allow other website owners to direct attention to specific imagery that's of interest without other stuff cluttering and getting in the way. It will also provide a way for them to jump straight from the widget out into a full version of the application in a new tab. So if they want to explore Worldview a little bit further or explore whatever's been embedded a little bit further, they can do that.
All right, back to me now. So we are kind of running out of time, but I'll just go over these last two slides. So as you saw in Worldview earlier, the daily imagery is often composited as each granule or swath is received. So there's often overlap of swaths on subsequent overpasses, especially at the poles. And missed that part here, but overlapping granules limit users' ability to access everything that a given satellite has acquired, especially in regions where there's likely to be swath overlap from previous overpasses. So this is the composite. And then feature enhancement will actually show you each individual swath or granule so that we can better support our near real-time and science users who monitor rapidly evolving events like fire, cloud, and volcanic activity, and also dust. And lastly, I saw we had a question in the chat about the Ghost GeoColor product, and it is indeed coming very soon. I think we're looking at mid-June. And this is a multispectral product composed of true color during the daytime and an infrared product that uses band 7 and 13 at night. So this will be coming very soon. And that is all. So thank you very much for tuning in to our webinar today. Please check out Worldview at worldview.earthdata.nasa.gov. You can also contribute to Worldview. The source code is on GitHub. And you can also bring the imagery into your own web application or GIS client at earthdata.nasa.gov/gibbs for instructions. Of course, as always, contact us for questions or comments. Thank you very much.
Okay, thanks, Minnie. At this point, we will transition to a final optional set of polling questions. We'll give these just a couple of minutes or so, and then we'll transition to the question and answer period. All right, thank you, everybody. Let's give this just a couple minutes. I answered the GeoColor question. Okay. And I really spoke to the next question, but the question was whether or not do the resources include projects or tutorials one could use to learn the functions and access the data before applying that knowledge to a unique problem or question. So either Minnie or...
Oh, sure, yes. Yes, like you mentioned, you can also watch that tutorial that we created last year. It appears that Jennifer already posted the link in the chat. You can also explore the Introduction to Worldview tour story that I introduced kind of at the end of my live demonstrations. We also have a handout, slightly older, but maybe we could also add that link somewhere as well, Jennifer, for the 4-pager handout.
Yes, exactly. And I can actually add that link to the Q&A pod. Let's see if we have any additional questions here. And there's also an RSET tutorial. I'm not sure what this refers to specifically. Are there any additional questions for our NASA Worldview speakers?
Hey, Jennifer, I'll jump in a second. So this is Ryan. I just wanted to, first of all, say thanks and great job to Minnie and Jason for the presentation today. So I wanted to talk specifically about a question from David Giles, who asked about adding several place marks or importing them into Worldview. I guess for one, since David, you and I have chatted in the past about AeroNet and adding things like that to Worldview, we do still plan to add those points to Worldview itself. So hopefully that will cover your use case. We hesitate a little bit to allow users to bring their own data into Worldview. We feel like we want to have users find data in Worldview and then export it out to something else like a GIS client. So one of the options there Minnie showed with exporting geotips into GIS clients. Another option which we didn't show was exporting Google Earth KMZs to either Google Earth Desktop or the web client. So those are two examples at least of ways to bring imagery out of Worldview into your own client. There's also ways to mass download, like bulk download imagery as well, if that's of interest. So we can get into that too later, or contact us if you're interested in that. One other point I wanted to make too that's unrelated to that was just, I saw some questions in there about geostationary and about retention periods. So as I think Jennifer noted, and so did the speakers, that it's a 30-day retention window for geostationary. And I to make it clear that that right now is only for geostationary, and everything else we retain indefinitely. So all the other missions, we have everything from the start of the mission to the present. I'm pretty sure that's true, at least. We do hope to extend that geostationary window a little bit. You know, it's mainly a disk storage issue at this point. Geostationary is pretty voluminous, and so we want to make it as reasonable as we can on our side in terms of disk storage.
Okay, thanks, Ryan. The next question is, we've actually got a couple. The first is, this individual, this user, is an artist from the UK who has received some funding to make data available through music, and wanted to ask about the permissions for using images or GIFs that are taken using the snapshot tool. You know, how should he credit any Worldview images properly? And I can certainly put a link to the citation policy, but if you wanted to speak to that really quickly, that would be useful.
Yeah, sure. As I said, I guess right at the beginning, actually NASA data are all free and available to use, so you don't actually need specific permission. We just ask that you credit us, and so Jennifer will post the citation information in the chat, but you can also get it when you go to Worldview and you click on the I button in the upper right corner and then click on About, and you'll find information on how to cite us as well.
Okay, perfect. Thanks, Minnie. The next question is, can geostationary data be added as a base layer?
That's a great question. I'd say we probably could do it. I don't know if Ryan, you have thoughts about that.
I suppose, yeah, we could do it. I guess the question would be why, though. I think overlays can do everything that base layers can, and more. So I'd be interested to know more about the use case on that.
Okay, thank you, Ryan.
Sorry, I just wanted to go back to the person who posted the RSET tutorial. They actually had a webinar today on fires and using Worldview for fires, as well as firms and other services. So that's probably why he posted it there. If you need Worldview from a different angle.
Thank you for that clarification, Minnie. Appreciate that. All right, perfect. The next, and so just as a follow-up to the question I asked just a moment ago regarding the geostationary layers, layers as a base layer, the users followed up and said, you know, coastlines and labels, for example, cannot be overlaid.
So, okay, got it now. That makes a lot more sense. So thanks for the clarification there. So I think that's we run into that issue in the past. It's basically, you can still rearrange the ordering of layers though. So you basically need to drag the labels and coastlines, for example, to be on top of the geostationary layers. So you'll be able to you'll be able to do that. You just need to kind of drag and drop that. But we've been considering basically building something in where those reference layers, like labels and the borders and so forth, are basically always on top of all the other layers. So right now you have to manually drag them. Whatever the most recent layer that you add to Worldview, that's the one that's on top. So if you already have coastlines and labels added, and then you add more layers, they're going to be potentially hidden by the overlays on top of that. So that's potentially a UI issue for us to work out, but it's also something that you can do as a user to reorder the layers yourself.
Okay, thank you, Ryan. And so while we're waiting to see whether or not we've got about 5 minutes left for the Q&A period. On the left-hand side in the bottom left, you will see the links that were on Minnie's slide, a link to NASA Worldview, the Snapshots tool, and additional links as well. Those are persistent features, so if you listen to the webinar via the direct link at a later point in time, you'll be able to interact with those relevant links. The PowerPoint slide deck is also available for download. You should see that in the bottom right corner of your screen. If you click on that, you'll be prompted with an option to download the file and then can select where you would like to have that saved to. So just scanning the I'd like to thank our speakers, Minnie and Jason, as well as our Q&A panelist, Ryan Bowler, and to thank all of you for joining us today. And we hope to see you at an upcoming webinar. All right, take care, everybody. At this point, we will log off from the audio component, and I'm going to take it back over to the polls. All right, thank you, everybody. Bye-bye now.